Now let's assume that we are rolling a die which is a fair die, which means any one of the 6 outputs 1 to 6 are equally likely to appear as the output. So in that case, what will be the sample space? The sample space S is going to be 1, 2, 3, 4, 5, 6. All these 6 outputs are equally likely, right? And now how are we going to assign the probabilities? Already we have seen that when there are 6 events and if all the events are equally likely, we are going to assign the probability of 1 by 6. Now how did we do that? See, let us assume that E is an event of getting 1 as the output, right? And if you want to find out P of E, some of the authors will also do this. It is not exactly right, but it is only applicable for the finite sets when S is finite and discrete events. Discrete event means non-continuous, right? So for such kind of system, you can even think of it this way. P of E, probability of E, is nothing but number of elements in E, n of E, divided by number of elements in S, cardinality. If it is possible to count, we can go that way. In case of continuous, let us say we are talking about the lifetime of a car, then the lifetime of a car can be anywhere from 0 to infinity. It is a continuous system and we will not be able to count the number of points, but then in this case we will be able to count the number of points. Therefore some of the authors, they even will try to assign it this way, and it will definitely work for this discrete events, and you can also do that. Okay, so what I mean to say is, if you are trying to find out the probability of an event, you can go with the number of elements in the event divided by total number of elements in the sample space. Now in this, number of elements is going to be 1 divided by total number of elements is going to be 6. That is why we got 1 by 6. Therefore for each of these simple events, right, so event of getting 1, event of getting 2, event of getting 3, so on, event of getting 6, we can give the probabilities 1 by 6, 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 right? Now these probabilities are going to change in case if you know something about the output. For example, if it is given that the output, the die is rolled and the output is one of the even numbers, if that is the case, which means, are you getting this? Now this is the one which we normally do. Now let us say someone has rolled the dice and you didn't see the output, and he told you that the output is an even number. Then these numbers are going to change. Why? Because the probability of getting any number other than even number is going to be 0, isn't it? Therefore the probability of getting a 1 is going to change to 0. Earlier it was 1 by 6, now it is going to change to 0. And probability of getting a 2, let's keep it that way, let's derive it later. And 3 is going to be 0, 4, let's leave it, 5 is going to be 0, right? Therefore now 3 events have become 0, and now there is only possibility of 3 events. Therefore now our new sample space will contain only 3 events. Are you getting this? Since it is already known that one of the even number has occurred, so I am directly assigning 0 to the odd numbers, and to the remaining even numbers I am supposed to assign some probability. See, initial probabilities were 1 by 6, 1 by 6, 1 by 6, 1 by 6, and now they have changed it to 0, 0, 0 for 3 numbers. Now for the other 3 numbers also I have to apply some probability here. Now what is the probability that you are going to apply to the remaining numbers? Now remaining numbers are 3, and we know that one of the 3 has occurred. Therefore again, since the original die was fair and all the outcomes were equally likely, now any of these 3 events are also going to be equally likely. We are not going to bias, but then we have only 3 elements. Now by this definition, if you see this, now if you want to find the probability of an event, it is going to be number of elements in the event divided by number of elements in the new sample space, right? So the number of elements in this event of getting 2 is 1, which means and then the number of elements in the new sample space. What will be new sample space? The new sample space S dash. If it is already known that we have got an output which is an even number, then the new sample space is going to be 2, 4, 6. Therefore, these probabilities are going to change as 1 by 3, 1 by 3 and 1 by 3. Got it? Let us say instead of this, if it is known that a prime number has occurred, then what will be our new sample space? Let's say instead of this 2 even number, someone has rolled the die and they said that the output is one of these prime numbers. Then what is our new sample space? Our new sample space is going to be either 2 or 3 or 5. So in this case, how will the probabilities change? For 1 it is 0 and for 2 it is 1 by 3. Why 1 by 3? Because the number of events is going to be 1 and the total number of events in the new sample space is 3. That is why 1 by 3. And what about this this one? 3 is also 1 by 3. And what about this 4? It is 0. What about this 5? 1 by 3. And what about this 0? Got it? So anyway, whatever the assignment of the probabilities are, they are all going to follow that rule. What is the rule? The probability assigned should be between 0 and 1. That is the first rule. And the second rule is the probabilities, when you sum them all up, you are going to get 1. If you add all this, we are going to get 1. If you add all this, we are going to get 1. If you add all this, we are going to get 1. So what is that I want you to observe here is, now let us say we have a sample space and now they have performed an experiment and they said that something has occurred. Then the new probabilities to the simple events, which means the points in the sample space, should change accordingly. That is what I want you to understand. Okay. Now let us say E is an event. Instead of S dash and S, let me say E. Let us assume that E is an event of getting a even number. Then what will be the probability of E? Now if you go by this definition, number of elements in E, 1, 2, 3 divided by number of elements in S, which is nothing but 1 by 6, 3 by 6. So 3 by 6, which is 1 by 2. Now let us say F is an event of getting a prime number. Now what is it I am talking about? I am just talking about an experiment in which a simple die is rolled, and now what is the probability of getting a even number? What is the probability of getting a prime number? Now these are not what I am talking about. This is what the case is. A simple fair die is rolled, and now what is the probability of getting an even number? The probability of getting an even number is 3 by 6. Why 3 by 6? Because number of elements in E is 3 and the number of elements in the sample space S is 6. That is why 3 by 6, which is 1 by 2. Then what is the probability of getting a prime number? Prime number is nothing but again 3 by 6. Why? Number of elements in F is 3 and number of elements in the sample space is 6, which is nothing but 1 by 2. Got it? Now what is the probability of E intersection F? Now what can you say about E intersection F? A number which is both even and prime, which is nothing but 2. Now what about P of E intersection F? P of E intersection F is nothing but 1 point is there and the total number of points is 6. That is why 1 by 6, which is, let's leave it that way, 1 by 6. Now these are the numbers we have. Okay. Now assume that they have already told you that, they have already told you this point. Let us say they already told you that the output is an even number. Okay, the question is like this: what is the words are very important here, that is why I am writing. What is the probability of getting a prime number given that an even number an even number showed up. Okay, so now they are asking about this. This is called as conditional probability. See, I'm going very detailed, in a very detailed manner, very slowly. The reason is this is very important topic. If you can understand this, we can go till Bayes theorem very easily. Just try to understand it. I'll be very slow. I'll be talking about really small things, really basics, but you should understand each and every point here. Otherwise, it will be very difficult for me to explain you other things later. Okay, so let's try to understand it everything. Now, what is the probability of getting a prime number given that an even number showed up? That is what we wanted. Now, how we represent it is called as conditional probability. Probability of getting f, which means a prime number given that e has already occurred. This is what we want. Okay, now there are various ways we can solve it. I'll show you all the ways. I mean, you can directly do it or you can apply these formulas, but then try to understand the formula, and whatever method you can solve it fast in the exam, you can use that. So see this one, already even number showed up. That is what we know. So these probabilities are going to change. How are they going to change? For the even numbers we are going to get the probabilities, and for the odd numbers we are going to get zeros, which means for 1 there is no probability, and for 3 there is no probability, and for 5 there is no probability, which means for odd numbers there is no way we are going to get anything. So we are applying zeros. We are not going to get odd numbers. For the even numbers, yes. So there are 3 even numbers, and all these 3 are equally likely to happen. That is why each one is going to get 1 by 3, 1 by 3 and 1 by 3, right? Now what is the question? What is the probability of getting a prime? Which means, what is the prime number now? Prime numbers are 2, 5, 2, 3 and 5. Now in this new probabilities, you have to find out the sum of the probabilities of getting 2, 3 and 5. Now 2, 3 and 5 is going to be simply 1 by 3. Therefore directly answer is 1 by 3. You know it, you can write it down. That is not what I am worried about, isn't it? Now can't you directly say this? Now from this new probability assignment, what they wanted is, what is the probability of getting a prime number? Now with the given information, you have changed the probabilities, and now among these changed probabilities you can apply that union theorem. What is union theorem? 2 union 3 union 5. Now 1 by 3 plus 0, which is 1 by 3. That is the answer. We can directly write it, right? But then I want to derive the steps, and I want to show you some other ways of doing it. Now see this. One event is event of getting a prime number, and other, this is event of getting a prime number, and this is event of getting an even number, right? Now it is already given that E has occurred. This event has already occurred. Okay, now they are asking what is the probability that F has to occur. If E has already occurred, and now if F has to occur, definitely the part which we should be interested is this, isn't it? Which means only the elements present in this are going to give us the required probability. Therefore this is going to depend on n of E intersection F divided by, earlier sample space was this entire thing, isn't it? But the now sample space is E. That is why we are only interested in number of E. Try to understand this one carefully. See this. Now are you following this? Let us say F is the event of getting a prime number and E is the event of getting an even number, right? And given that E has already occurred, which means now our new sample space contains only this part. Now what is the probability of getting this part? So what is that they are saying? Already now we know that this one has occurred. Now what can we say about this part? How much probability do you want to assign to this part, right? And we know how to assign the probabilities. So what is it? We count the number of elements in this in case of discrete elements, and then we count the number of elements in this. Now the number of elements in this part divided by total number of elements in this part is going to give us the required probability, which is nothing but n of E intersection F divided by n of E. Now what is n of E intersection F? Now what can we assign? What is the number of elements in the intersection? The number of elements in the intersection is going to be, if you take these two, intersection is going to be only 1, which is nothing but 2. If you take the intersection, it is only 1, right? So which means 1 divided by, what about n of e? So how many elements are there in e? If you look at e, it is going to be 3 elements. 1 by 3 is the answer, right? Either you can get like this, or you can apply that formula and get it. Or the standard way is, now I am just trying to divide this one, n of e intersection f divided by n of s. N of s is original sample space, divided by n of e divided by n of s, which means I am just dividing the numerator and denominator with number of elements in the sample space. Numerator and denominator I am just dividing with number of elements in the sample space. And we already know that if you take an event, if you take the number of elements in the event, and if you take the sample space and if you divide it, we are going to get the probabilities, which are nothing but the original probabilities, not the changed probabilities, right? So that is how I can write this as P of E intersection F divided by P of E, isn't it? P of E intersection F divided by P of E. Now these probabilities are original probabilities. So what is the difference between using this method where you change the probabilities and then you take the union, and this one? The difference is you need not change the probabilities. You can take the original probabilities, just think that the die is fair, and you apply the original probabilities, and using those original probabilities itself we can apply this formula and get the answer. See this? Now in the original probabilities, what is P of E intersection F? What is probability of getting 2? P of E intersection F is 1 by 6, isn't it? Original probabilities, not the changed ones. And what about P of E? P of E is 1 by 2, right, which is nothing but 2 by 6, which is equal to 1 by 3. Again we got 1 by 3. Got it? So what is that I did? I have changed the probabilities and I have summed them up. Here also I got 1 by 3. When I sum this one and this one, here also I got 1 by 3. Or I have found out this method in which I'll find out the number of elements in the intersection part and the total number of elements in the part that has already occurred. There also I got 1 by 3. Or I have found out that probability of E intersection F divided by probability of E, which is 1 by 3. So which one is the easier for you? You might intuitively feel that this is the easiest one, or you might feel that this is the easiest one. Yes, they are easy, but then if you think deep, you are not actually changing anything. You are actually writing these numbers and you are directly using this formula and getting it. So this one is easier actually. Okay, so whatever method you like, you can answer the question, but then I recommend that you just remember this one: P of probability that an event F will occur, given that the probability E has already occurred, is equal to probability that F and E will occur divided by probability of E. This is called as conditional probability, right? The conditional probability that F will occur given that E will occur. Why is it called conditional probability? Because we are discussing about what will be the probability of an event given that other event has already occurred. That is the condition we are applying. That is why it is called as conditional probability, right? So now let's see one more example. I think you understood this clearly, right? So if you didn't understand it, please rewind it and then again watch the video completely from the beginning. It is really the beginning, this part. From here we are going to get into, next one is multiplication theorem, and then total probability, and then Bayes theorem. So if you have to understand all these theorems well, you should understand this one really well. Okay, fine. Now try to understand this one with one more example. Let us say I am having 2 dice and I am rolling 2 dice, and it is already known that there is 4 on the first die. So let us say the experiment is now rolling 2 dice, 2 fair dice, okay, and E is an event that the first dice is 4. Then what are the elements in this event? 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, isn't it? E is an event in which this is the case. So these are the elements. Now what can you say? What is this sample space? Actually, the original sample space will contain 36 elements. If you are rolling 2 dice, then the original sample space will contain 36 elements, 6 into 6, right? And the probability of each simple event is going to be 1 by 36 because all are equally likely. And now in this event we have 6 elements. That is why the probability of this event E is going to be 6 by 36, because probability of each event is 1 by 36. Since we have 6, it is going to be 6 by 36, which is nothing but 1 by 6, right? And let us define one more event F. Let F be an event in which the sum of outcomes is 6. Okay, so which means if I see the sum of outcomes on both the dice, then if I add them up, it has to be 6. So what are the possibilities? 1 5 and then 5 1, both are going to give us 6, and then 2 4 and then 4 2, both are going to give us 6, and then 3 3, it is also going to give us 6, right? Now what is the probability of probability of F? Probability of F is, it is going to contain 1 2 3 4 5. 5 elements are there, that is why it is going to be 5 by 6, isn't it? Now assume that E has already occurred. What is the probability of F occurring? Which means, given that first die has turned up to be 4, what is the probability that sum of the dice is going to be 6? Which means probability of F given E. Now how are you going to do this? You can do it in various ways, right? So one method is you can use this, or you can change the probabilities and do that. See, in the original sample space there were 36 elements and each element was taking a probability of 1 by 36. Now once the condition has been applied, what is the condition? The first die has turned up to be 4. Now all the remaining elements will become 0. All the probability of the remaining elements. What are the remaining elements? The remaining 30 elements will take the probability 0, and these 6 elements are equally likely to happen. Why? Because the original elements are equally likely to happen, because therefore any of the 6 elements are equally likely to happen. Now how many elements are there? 6 elements. So you can apply 1 by 6 to each one of them. 1 by 6, 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 because there are only 6 elements. Now what is the element that we are interested in? Now from this sample space we are interested in the element in which the sum is 6, which means we are interested only in this one. Therefore what is the answer? 1 by 6. The probability of getting a sum as 6, given that first die has turned up 4, is 1 by 6. You can directly say it, right, by this method, by changing the probabilities. Otherwise the second method is you can count the number of elements. How many number of elements are there? 6 elements. And then how many number of elements are there in E intersection F? Only one element, which is 4 2. Therefore you can use this method, which means 1 by 3. Or the third method, which I suggest that you always use, is P of F intersection E is equal, P of F given E is P of F intersection E divided by P of E. Now let's try to find out what is P of F intersection E. Now P of F intersection E is nothing but, how many elements are present in this intersection? Only one, right? Therefore it is 1 by 36. See, this probability is the original probability before knowing the condition, isn't it? That is the beauty of this formula. Even without changing the probabilities, we can know the original probabilities and we can work out the answer. So F intersection S is 1 by 36, right? So what is the answer? P of F given E is P of F intersection E, which means 1 by 36 divided by P of E. What is P of E? P of E is 1 by 6. That equal to how much? It is nothing but 1 by 6. This is the answer. Alright, so you can easily do that. So let's do one more example. Let us say there is an event. Again we are rolling 2 dice. Now the event E is that we got 2 odd numbers, right? So assume that we are talking about event E. We have rolled 2 dice, and event E is the event in which both the dice have shown up odd numbers. Then how many will be there? If both the dice have shown up odd numbers, then it will be 1 1, 1 3, 1 5, right? And then 3 1, 3 3, 3 5, and then 5 1, 5 3, 5 5. So 3 odd numbers are there, so 3 into 3 is going to be 9, right? And let us say the second event f is the event in which the sum is 6. So the event in which sum is 6. If the sum has to be 6, then what are the possibilities that we are going to take? We are going to take one is 1 5 and other is 5 1, right? 1 5 5 1, and then 2 4 and 4 2, as well as 3 3, right? Now what is the probability of getting f given that e has occurred, which means if it is already known that both the outcomes on the dice is an or even or odd numbers, then what is the probability that sum of the dice is actually 6? If that is the question, how are you going to answer it? Now again, we can do in all the three methods. You can choose any of these three methods, right? So what is the first method? What are the changed probabilities? Originally it was containing 36 elements, and each element was getting 1 by 36 as the probability. But now after the condition has applied, which means the event E has occurred, now out of this 36, right, 9 events has occurred, and 36 minus 9 events will get 0 as the probability. For these 9 events, the probability will become 1 by 9, right? All of these events are going to take the probability 1 by 9, right? And now in this one, just choose what is the output that you wanted. What is the output that you wanted? The sum has to be 6. Just choose how many are there. So if the sum has to be 6, this is there 1 comma 5 and 5 comma 1 and 3 comma 3, right? So these are the three items we have. Therefore it is going to be 3 by 9, isn't it, directly, which is 1 by 3, right? Otherwise, what is the other method? You can find out what is intersection part. Intersection part, we did the same thing, right? What is the intersection part? The intersection part is 3, and what is the total? The total is 9. Therefore 3 by 9, again we get 6, 1 by 3. And what about the other one? The other one is P of f is P of f intersection E divided by P of E. Now what about P of f intersection E? P of f intersection E is nothing but it contains only 3 elements, which is 3 by 36, right? Divided by what is P of E? What is P of E? E contains 9 elements, which is 9 by 36, which is nothing but 1 by 3. You can go by any method, you are going to get this, right? So what I mean to say is, conditional probability is a way of finding out a probability of one event given that other has already occurred. That is the condition. This is what we are looking at. Got it? So using this, using this formula, this one, we are going to do many problems, right? So I'll take all the problems one by one and I'll explain you. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.